and I hope everybody is having a wonderful day. Today we're going to start our discussion about least common multiple. What it is, how we can identify it, and why we would identify it. So a least common multiple, why do we really need to know? Why do we care? When we have situations where we have to purchase multiple different items for maybe a party or for a field trip, and each item is packed differently. The first example that comes to my mind is hot dogs and hot dog buns. You never find the same number of hot dog buns in a package as you do hot dogs themselves. So in order to figure out how much we could buy in order for them to match so we don't have anything left over, we would need to figure out what the least common multiple of both of those numbers or quantities is. Another situation where we could find the least common multiple is if we have an event that's reoccurring. So, and we want to figure out when it's going to occur again. For example, if I'm meeting with my boss every 3 days, and my boss is meeting with his boss every 2 days, well, when does that happen at the same time if we both had our meeting today? So when would the next time be that we would both have our meeting? We would have to find the least common multiple of my every 3 days and his every 2 days to help us out. So any repeated events or when we are purchasing multiple items. Okay, that's why. What is least common multiple? The least common multiple is actually just the smallest common multiple that a set of values both have or all have. Okay, because so it could be 2 or more. So they all have this multiple in common. Reminding ourselves that a multiple is actually a product. Okay, in elementary we're thinking skip counting. So 4 is a multiple of 2. 20 is a multiple of 10, 2, and 5. Because you can skip count by 2 to get 20, 5 to get 20, and 10 to get 20. Also 4. Okay, so the multiple is actually the product here. How can we find the least common multiple? It would be our next question. I'm going to show you 3 different methods. There are a lot of more methods, but I personally find that these 3 just seem to be a lot easier to understand. The first method that I'm going to discuss and talk about in order to find the least common multiple of a set of numbers, it could be a set of 2 or more numbers, is utilizing what we know about fractions. Okay. You can also do what's called the ladder method in this case, which is basically the same thing. So if I wanted to find the least common multiple of 9 and 12, and if you want to find out more about that ladder method, there are tons of videos on it, so I'm not going to totally include that one in here. But we can think of these 2 values as a fraction first. Okay? When we see a fraction, we always want to reduce that fraction. So after we reduce it, okay, we realize, well, wait a minute, this is our greatest common factor, if we remember right, okay? That the value, the biggest value that we can divide both numbers by, that's our greatest common factor. Our least common multiple is actually the product of all of the factors. Okay? So all of these factors, the 3, the 4, and this 3, create our least common multiple. Okay? So 3 times 4 is 12, times 3 is 36. And quick check, that 36, the least common multiple being a product of numbers, so it's going to be large, is bigger, or it could also be equal to the largest one of the given values. So this is actually bigger. And that is our answer. Okay. The next method. The next method I'm going to show you is basically elementary. It's the skip counting method. Okay. So if all else fails, you could probably figure out how to skip count and figure out the least common multiple of two different numbers using the skip counting method. So I'm going to take a couple numbers of 12 and 15, and I'm taking these numbers for a reason. Okay. When we skip count, we have to rely on how well we're multiplying. Okay, so 12 times 1 is 12. That's where we all start. And then if we count by 12s each time, well, 12 times 2 is 24, 12 times 3 is 36, 12 times 4 is 48, and 12 times 5 is 60. We realize that multiples continue forever. Okay, I normally just do about 5 or 6, and then I give it a rest, and I go to the next one. Okay. Well, 15 times 1 is going to be 15. 15 times 2 is 30. 15 times 3 is 45. And I add 15 each time, essentially. And I could keep going if I do not see a number in common. However, I lucked out, and I see a number in common right away. The downfall to skip counting is if you're inaccurate on one, so if I thought that this was 35, I'm going to be inaccurate on all of the rest of them. Okay. So if we're not very proficient in our skip counting, that might be our downfall here. Another downfall of skip counting is sometimes these lists can go pretty high. Okay. Sometimes the common multiple is very big, even though it's the least common multiple. But you have that strategy to utilize. The third method that I'm going to show you, the third method I'm going to show you, well, we talked about the fractions, we talked about skip counting. The third method I'm going to show you is using or utilizing what we know about the prime factorizations. Okay, so this is the prime factorization method. Again, I'm going to take two values. Let's just do, well, let's do 8 and 12. That sounds good. 8 and 12, okay? Well, we first have to prime factorize both of these. In other words, we're using that factor tree. So 8, when we use that factor tree, we get 2 times 2 times 2. Again, we have to keep going until we get all those primes in order to create the product of 8. 12, well, 4 times 3 is a possibility. Everybody's factor tree might look different, but in the end, we're going to get the same prime numbers if we do it properly. To utilize prime factorization to find the least common multiple, maybe, here we go. Okay. Now we have our lists. So 8 became 2 times 2 times 2. We still have to realize that we have some pairs here. We have a pair of 2's and another pair of 2's. Okay? Which means when we're making the list of the prime factors, we have to match those pairs up. So 12 has 2 of the prime factors of 2. So I'm going to match them up. Okay. It does not have a third 2. It has instead of 3. Okay? So the 3 cannot match up with anything, and neither can this 2. So in order to ensure that the least common multiple has all of the factors that it needs, it needs a 2, another 2, a third 2, and a 3. Now all we do is simply we multiply these factors. 2 times 2 is 4, times 2 is 8, times 3 is 24. And we realize that the least common multiple, in this case, the least common multiple of 8 and 12 is 24. Doing a quick check, well, yes, that's true, because 8 times 3 is 24, and 12 times 2 is 24. That's fairly low, so that must be the least common multiple. Oops. When we have variables, monomials, okay, so when we are finding the least common multiple of monomials, there is a slight difference. I'm going to show you the fraction format. If we have the monomials of 20x and 100x squared. I'm going to start off easy. Okay? We're going to section this out, and we're just going to do the coefficients, the values, the numbers, and then we're going to do the variables. Okay? Write them as a fraction. And I always like to break up those variables right away. Okay? I realize that they have an x in common, so I know I'm going to end up dividing by an x. X divided by x is 1, x divided by x is 1, so it basically cancels that out. I'm looking at my numerical values, and I realize, well, 20 and 100, I can divide both of those by 20. Okay? So I can divide both of them by 20x right away. 20x divided by 20x is going to equal 1. 100 divided by 20 is 5. We took out 1x because we divided it out, but there's still 1x left. Using the least common multiple strategy, we make ourselves a little L. Oops. We try to. Okay? And we utilize all of the factors that we have to create our multiple. Excuse me. By multiplying all of the factors, we find the least common multiple is 20x times 5 times 1. Well, do the numbers first. 5 times 20 is 100. X times x is x squared. The least common multiple in this case is 100x squared. Notice it's equal to the largest of the two that we're given. That's okay as long as it is not smaller. Okay? Using the factor tree or prime factorization method real quick. Okay. 20 would give us 2 2's and a 5. X is just going to be x. 100 is going to give us a 5, 2 5's, a 2, and another 2. Okay. The x squared is going to give us 2 x's. Now we look for what's in common and we create our lists. Oops. So 20x, we get the 2 times the 2 times a 5, leave a little space just in case, times this x. The 100, x squared, we have 2 2's, 2 5's, and 2 x's. If they match up, if they have a pair, you just bring that number down. Okay? If they don't, you still have to bring that number down. Or that value down, I should say. And then we just multiply all these values. So 2 times 2 is 4, times 5 is 20, times 5 is 100. X times x is x squared. Our least common multiple is x squared. And that is how I just showed you 2 different methods you can utilize to find the least common multiple of a set of 2 monomials. If you have a third one, you're using the same process. But just realizing that, oops, you're going to have to add that extra number. So if I had 15x cubed here, I would do the 3 over here, a 5 matched up with all 3 of them, x, an x matched up here and an